Hello dear students, all of you welcome to Vidyayana classes. Today we will discuss some expected board questions on maxima and minima. So that the shortest distance of the point 0, 8a order pair from the curve as square is equal to yq is 2a into root of 11 where a greater than 0. Answer: as square is equal to yq is the given curve. It is symmetry to y axis and passing through origin. Even power of x is present, so it is symmetry to y axis. For x equal to 0, y is also 0, so the curve passes through origin. The graph of the function as follows. As square is equal to yq. It is symmetry to y axis. Let pxy be the any point on the curve. Q is the point 0, 8a order pair. Clear? Let pxy be any point on the curve. The distance from pxy to u08a is mod of pq, which is equal to x minus 0 square plus y minus 8a square. It's the square root, which implies as square of mod of pq is equal to square root of s square plus y minus 8. Sorry. Clear? Which is same as yq divided by a plus y minus 8 whole square as s square is equal to yq. Clear? S square is equal to yq, so s square is equal to yq divided by a. Clear? Okay. Here mod of pq, its square is equal to yq divided by a plus y minus 8a whole square. It is the function of y. It is the function of y say. Here u is the function of mod of square of mod of pq is equal to u, where u is the function of y, which implies as uy is equal to yq divided by a plus y minus 8a whole square. Differentiating both the sides with respect to y, which implies as u dash y is equal to 3y square divided by a plus 2 into y minus 8a. Clear? Okay. Again differentiating with respect to y, which gives u double dash y is equal to 6y divided by a plus 2, which is greater than 0. Since what is y? Y greater than 0 or equal to 0. Since y greater than or equal to 0. Clear? Which implies as u double dash y greater than 0. Second derivative greater than 0. That implies u is minimum. That is the distance between P and Q is minimum or shortest. U is minimum. U is the function of the distance. U minimum, distance minimum. Clear? For shortest distance, u dash y is equal to 0, which implies as u dash y is equal to 3y square divided by a plus 2 into y minus 8a is equal to 0, which implies as 3y square plus 2ay minus 16 square is equal to 0. Clear? Clear? Okay. By the middle fraction, 3y square, 8ay minus 6ay minus 16a square is equal to 0. Clear? Y taking common, 3y plus 8a, 2a taking common, 3y plus 8a is equal to 0. Clear? Clear? Okay. 3y plus 8a into y minus 2a is equal to 0, which implies 3a plus 8a is equal to 0, which implies 3y. Y is equal to minus 8a divided by 3 is impossible. As y greater than or equal to 0. Y is positive and a greater than 0. When a greater than 0, y will be negative. So y is equal to minus 8a divided by 3 is impossible. Now, or y minus 2a is equal to 0, which implies y is equal to 2a. Clear? Y is equal to 2a. Mod of PQ is equal to square root of distance between P and Q, which is equal to square root of s square plus y minus 8a whole square, which is same as s square is y cube divided by a plus y minus 8a whole square root, which is equal to square root of y is equal to a, that is 8a cube divided by a plus minus 6a whole square, which is equal to 8a square plus 36a square root. Here, which is equal to 44a square root, which is equal to 2 into root of 11a. Here, the minimum distance between P and Q is therefore the shortest distance of the point 0.08a from the curve is 2a root of 11 hence proved. Clear? Next question. Find the altitude of a right circular cylinder of maximum volume inscribed in a sphere of radius r. Given r is the radius of a sphere, let h is equal to 2x be the height of let h is equal to 2x be the height r be the radius of base and v be the volume of the cylinder. R is the radius of the given sphere. Let h is equal to x be the height and r be the radius of base and v be the volume of the cylinder. It is cylinder ABEF. Clear? Find the altitude of a right circular cylinder when the volume is maximum. Volume of the cylinder V is equal to pi r square. Capital R is the radius of the base of the cylinder, pi r square h. What is h? That is 2x, which is equal to pi r square. It is a right hand triangle. OCB is a right hand triangle. Capital R square is equal to small r square minus s square into 2x. Clear? Which implies as v the function of x. Vx is equal to 2 pi r square into x minus 2 pi s cube. Clear? V the function of x. So V is equal to 2 pi r square x 2 pi s cube. Differentiating both the sides with respect to x. V dash x is equal to 2 pi r square into 1 minus 6 pi s square. Clear? Again differentiating both the sides with respect to x. V double dash x is equal to 0 minus 12 pi x, which is equal to minus 12 pi x less than 0, since x greater than 0, and 2x is the height of the cylinder. H is greater than 0, so x greater than 0. V double dash x less than 0 implies this V is maximum. So the given statement is true. The volume of the cylinder is maximum. For maximum volume implies as V dash x is equal to 0. V dash is equal to 2 pi r square minus 6 pi s square is equal to 0, which implies as 6 pi s square is equal to 2 pi r square, which implies as s square is equal to pi cancel, it is 2, it is 3, r square divided by 3, which implies as x is equal to positive square root of r divided by root 3. Clear? Since x is positive, which implies as h is equal to 2x is equal to 2r divided by root 3. Is the altitude of the right circular cylinder. Therefore, the altitude or height of the right circular cylinder is 2r by root 3. Clear? Next question. Find the extreme values of fx equal to x divided by 1 minus s square when x greater than minus 1 less than 0, and SQ minus x when x greater than or equal to 0 and less than 2 on open bracket minus 1 2. Answer: fx is equal to x divided by 1 minus s square when x greater than minus 1 less than 0. SQ minus x when x greater than or equal to 0 less than 2. Differentiating both the sides with respect to x implies this: f dash x is equal to 1 minus s square into 1 minus x into minus 2x whole divided by square of 1 minus s square. Clear? Okay. When x greater than minus 1 less than 0. 3s square minus 1 when x greater than or equal to 0 less than 2, which is same as 1 minus s square plus 2s square, that is 1 plus s square divided by square of 1 minus s square. X greater than minus 1 less than 0. 3s square minus 1 when x greater than or equal to 0 less than 2. Clear? Clear? Okay. Find the extreme values at the extreme point f dash x is equal to 0. F dash x is equal to, which implies is 1 plus s square divided by square of 1 minus s square equal to 0 when x greater than minus 1 less than plus 1. Clear? Which implies 1 plus s square is equal to 0, which implies is s square is equal to minus 1. Is impossible. Clear? Okay. And f dash x is equal to 0 when x greater than or equal to 0 less than 2. F dash x in this interval, f dash x is equal to 3s square minus 1 is equal to 0. S square is equal to 1 by 3, which implies this x is equal to 1 by root 3. Positive square root 1 by root 3 as x greater than equal to 0 less than 2. X equal to 1 by root 3 is the extreme point on close bracket 0 to 2 open bracket. Clear? Find the extreme values. The value can be obtained from the function f 1 by root 3, f of 1 by root 3, which is equal to 1 by root 3 whole cube minus 1 by root 3, which is equal to 3 root 3 minus 1 by root 3, which is same as 3 root 3 1 minus 3, which is equal to minus 2 divided by 3 root 3, which is same as minus 2 root 3 divided by 9. Therefore, the extreme value is minus 2 root 3 divided by 9. Clear? Next question. Rules of finding points of inflection. First point, fx is continuous at x equal to a. Second point, x equal to a is the point of inflection if f double dash a equal to 0 or a is a root of f double dash x is equal to 0. Third condition, f double dash a minus h and f double dash a plus h are opposite signs. Note, if x equal to a is a point of inflection, then it is neither maximum nor minimum point. Clear? So that x equal to 0 is the inflection point for fx equal to s cube for all x belongs to R. If x equal to 0 is a inflection point, it is satisfied the above three conditions. Clear? Answer. fx is equal to s cube is a polynomial function of degree 3, implies f is continuous at x equal to 0. Since every polynomial function is continuous, the first condition is satisfied. Clear? Second condition, fx is equal to s cube implies f dash x is equal to 3x square, which implies f double dash x is equal to 6x. Clear? f double dash x is equal to 0, that is equal to 6x is equal to 0. X is equal to 0. The second condition is satisfied, that is 0 is a root of f double dash x equal to 0. Clear? So the second condition is satisfied. Third condition, f double dash 0 minus h, f double dash is equal to 6x. 6 0 minus h is equal to minus 6h is less than 0 as h tends to 0, h greater than 0. That means h is arbitrarily very small positive number. Second condition, f double dash 0 plus h is equal to 6 0 plus h is equal to 6h greater than 0. Since h greater than 0, h tends to 0. All three conditions are satisfied. All three conditions are satisfied. Therefore, x equal to 0 is the point of inflection. That is, x equal to 0 is neither maximum nor minimum point. Clear? Clear? Next question. If phi x is equal to fx plus f1 minus x, f double dash x equal to 0, for x greater than equal to 0, less than equal to 1, then show that x equal to half is the point of inflection. That is neither maximum nor minimum point. Answer. X equal to half is the point of inflection. If first condition phi x is continuous at x equal to half. Second condition phi double dash half is equal to 0. Third condition phi double dash half minus h and phi double dash half plus h are opposite sides. Clear? If these three conditions are satisfied, then x equal to half is the point of inflection. Given phi x is equal to fx plus f1 minus x. Differentiating both the sides with respect to x, which implies this. Phi dash x is equal to f dash x plus f dash 1 minus x into minus 1. Again differentiating both the sides with respect to x, which implies this. Phi double dash x is equal to f double dash x plus f double dash 1 minus x. Clear? F dash x, now f dash x and f dash 1 minus x are exist. The derivative of fx and the derivative of 1 minus x are exist. Implies this. Fx and f1 minus x are continuous. At x equal to half. Or exist at x equal to half. Every differential function is continuous. As f dash x and f dash 1 minus x are exist at x equal to half, implies this fx and f1 minus x are continuous at x equal to half. Sum of two continuous function is continuous. Plus f1 minus x is continuous at x equal to half. Since f and fx and f1 minus x are continuous at x equal to half, its sum is continuous at x equal to half. Implies this fx plus f1 minus x is phi x is continuous. At x equal to half. It is the first condition. The first condition is satisfied. That is all. Clear? Second condition. Phi double dash x is equal to f double dash x plus f double dash 1 minus x, which implies this phi double dash half is equal to f double dash half f double dash 1 minus half, that is the half, which is equal to 0 plus 0 is equal to 0. Since f double dash x is equal to 0 for all x greater than equal to 0 less than equal to 1 given. Clear? Implies this phi double dash half is equal to 0 is the second condition is proved. Clear? Third condition. What is the third condition? F double dash, phi double dash half minus h and phi double dash half plus h are opposite signs. Phi double dash half minus h, which is the same as f double dash half minus h plus f double dash 1 minus half minus h, that is the half plus h. This value is 0, this value is also 0. Since half minus h lies between 0 to 1, which is equal to 0. Phi double dash half plus h is equal to f double dash half plus h plus f double dash 1 minus of half plus h, that is 1 minus h, half minus h. Clear? This value is also 0, this value is also 0. Since half plus h lies between 0 to 1, which is equal to 0, is equal to minus 0. The value of 0 is 0 is equal to minus 0, which is equal to minus phi double dash 1 half plus h. Implies this phi double dash half plus h is and phi double dash, it is minus, half minus h are opposite sides. So the third condition is satisfied. Clear? Therefore, x is equal to half is the point of inflection. That is neither maximum nor either maximum nor minimum point. Hence proved. Clear? Clear? Okay. Next, first derivative test for an estimum. Let f dash a equal to 0. That means a is the critical point for the continuous function f. For relative or local maximum at x equal to a. If f dash a minus h greater than 0 and f dash a plus h less than 0, then f is the maximum at x equal to a. And f is the maximum value of fx. In other words, we can say if the derivative changes its sign, that is positive to negative, moving from left to right, attains the maximum position. For relative or local minimum at x equal to a, if f dash a minus h less than 0 and f dash a plus h greater than 0, then f is a minimum at x equal to a and f is the minimum value of fx. In other words, we can say if the derivative changes its sign, that is negative to positive, moving from left to right, attains the minimum position. Clear? Question: answer with reason whether the following function has a relative or local maximum at x equal to 2 or not. Answer: y equal to fx is equal to x if x greater than equal to 0 less than 1 and 1 if x greater than equal to 1 less than equal to 2 and 3 minus x when x greater than 2 less than equal to 3. One, 2 and 3. It is 1 0, it is 2 0, it is 3 0. Y equal to x when x varies 0 to 1. Y is equal to x. From 1 to 2, y is equal to 1. From 2 to 3, y is equal to 3 minus x. Y is equal to 3 minus x and it is y is equal to 1. At x equal to 1, y is equal to 1. It is 1 1. At x equal to 2, it is this point is 2 1. At x equal to 2, y is equal to 1. At x equal to 1, y is equal to 1. Clear? It is the graph of the given function. F dash x, derivative of x is equal to 1. When x greater than equal to 0, less than 1. Derivative 1 is 0. When x greater than equal to 1, less than equal to 2. And minus 1 when x greater than 2 less than equal to 3. Clear? Now f dash 2 minus h, that means x less than 2, the derivative is 0. F dash 2 plus h. That means x greater than 2. The derivative is equal to minus 1. Clear? Clear? F dash 2 minus is not equal to f dash 2 plus. 2 plus means 2 plus h. Clear? Which implies this f dash 2 does not exist. Clear? F dash 2 does not, left derivative at x equal to is not equal to right derivative at x equal to 2. So f dash 2 does not exist. Clear? Implies this and f dash x does not changes its sign when passes through at x is equal to 2. Clear? F dash left derivative is not equal to x, so f dash 2 does not exist, and f dash x does not changes its sign when passes through at x equal to 2. Clear? Therefore, if the derivative changes its sign moving from left to right at x equal to a, then it is either maximum or minimum point. But here the derivative does not change its sign when passes through at x equal to 2. Therefore, the question is given, answer with the reasons whether the following function has a relative, that is local maximum at x equal to 2. Therefore, the function defined by as no relative extremum at x equal to 2, but it has absolute maximum value at x equal to 2. Clear? It has absolute maximum value at x equal to, its maximum value is 1, but it has no relative extremum value. Extremum means either maximum or minimum. It has no extreme value at x equal to 2, since the derivative does not change its sign at x equal to 2. Clear? Clear? Okay.